So this next January would be a great time to visit Maui. The prices for airfares are down way lower than normal. It would be only like $500 a ticket, which is way cheaper than even getting to Florida. But you also have to pay for this. The gas prices have gone up lately, and so therefore it's like $600 a ticket. But it's still a great time to go to Maui. One of the things that's cool about Maui is you can just go right off the beach and where you used to be swimming around. If you put on goggles and get a snorkel so you can stay under a little bit, you can see so many fish. And there's one kind of fish that I think is the most pretty, and they are the angelfish. So we're saying X equals angelfish. And there's another kind of fish that we're going to call Y, called the humu humu nuku nuku apu apu ai. I am not making that up. I'm probably pronouncing it wrong. It's a million letters, and it is the Hawaiian state fish. We're going to call it the humu. That's what the locals call it, the humu. All right, and the humu fish is totally different. Oh, can't see the board. The humu fish is totally different than the angelfish. You totally can tell them apart. I will say of the angelfish, there's like a million varieties. They are so brightly colored and amazing. They're just awesome looking fish. All right, sorry we're having some tech issues. Looks like it might have disconnected me. There we go. Good. Angelfish and humus. All right, we're going to be trying to make one of those really hard linear programming questions. They're so hard, in fact, that if we just gave you one big problem, do you get if you just graphed one of your lines wrong, then the intersection points would be wrong, and then the whole thing would be wrong? And that's not a great way to give a test, that if you make one mistake, the whole thing's wrong, right? So what we do is we break it up into little parts, and we might say, for this problem, just give me the constraints. Now, for some of you, you're like, what the heck's a constraint? Would you please talk to the kid next to you about what do they mean when they say constraint? All right. Did you know that they're talking about equations? All right, so let's do some constraints for this. So you go out swimming around out there, and you're going to see at least 12 fish. That's an equation. You're going to see at least 12 fish. Now you might be like, but you didn't tell me angelfish or humus. You're right, I didn't. But it's still an equation. You're going to see at least 12 fish. All right, here's another constraint. You're typically going to see about 5 times as many angelfish as humus. Now that's 2 constraints. Now the real world constraints is you can't have negative angelfish. So, but wait, we're going to have a one that's more important than that. In fact, from my experience, you could, and I've never gone out there, as far as I can remember, and swam around and looked and seen, at least I see 2 angelfish. So instead of saying x is greater than or equal to 0, I'm going to say, you're going to see at least 2 angelfish. Yes?
You said that it's going to be around 5 times?
Oh, no. I said at least 5 times. At least 5 times as many angelfish as humus. All right. I think that's enough constraints so far. Would you please talk to the kid next to you about the constraints? Okay. Now, I know there's people even debating which way that 5 times thing goes. And I understand. It's very confusing. So here's what I would normally want to write. I'd want to go 5 times the angelfish is the humus, but that's wrong. That's not how you do it. Because the angelfish number, which is x, is way bigger. You can't take 5 and times it by the bigger number and make them equal. If you want to make them equal, you take the smaller number, which is the humus, and times it by 5. Does that make sense to you? All right. And then there's the at least part. Well, just to make sure, if I go like 52 to 10, wouldn't that be at least 5 times as many angelfish? I'm making up numbers here. So that I can put those in and go, okay, if I had 52 angelfish and 10 of these, then which way would the sign go? Oh, it'd be this way. See what I did there? I just to check it, just to make sure I did it right. So x is greater than or equal to y, no, not just y, 5 times that smaller number. 5y. Raise your hand if you got that one right. I'm just curious. Okay. And that's not everybody. It's backwards from what it seems like it should be sometimes. But the way you check it is make up a number that is at least 5 times as many. If you want it to be exactly 5 times as many, sure, just make it 50. But then you can't tell which way the sign should go. See? All right. All right, so there's 2 constraints. Now, I also, actually, sorry, that's 1. I also said something, Mr. Breen, about how many fish I was going to see. Can you tell me that equation?
X is greater or equal to 2.
That's about the angelfish in particular, that there must be at least 2 angelfish. That's correct. But what's the other one about the total fish?
Oh, X plus Y is greater than or equal to 12.
Greater than or equal to 12. Good. Now, those 3 are enough to make a nice little graph. We're going to take a second. I don't want you to use graph paper. Why? Because I really want you to find where those 2 lines cross by using algebra. All right, so let's just make a quick sketch of this thing. This one, it'd be really smart to solve it for y.
Why?
So I'm going to go take away x, and I'll get y is greater than or equal to negative x plus 12. There's 2 reasons it's smart to solve it for y. Number 1, if you were going to put it into a calculator, the calculator has a screen that says y equals. So that's a good reason. All right. The other good reason is now I've got it in slope-intercept form. I know I can start at 12. And then I know how the slope is going to look. Quan, can you tell me if I go down 1 over 1, down 1 over 1, down 1 over 1, do you know where I'm going to hit when I get to the bottom? 12. Yep. Now, if I said greater than or equal to, which way should I shade? Now, the kids who have trouble with shading, I've noticed this. When they ask me, I can't tell which way to shade. They're thinking about it in terms of left or right. Don't do that. Greater than doesn't mean left or right. Greater than means above. And I think everybody knows greater goes with above and less goes with below. That makes sense, right? So if I want greater than, I'm going to shade above the yellow line. And if you think about it long enough, you can figure out which way above the yellow line is. All right. Now we can put in these other 2 equations. That one and that one. And I would solve it for y before I graphed it. I'm going to take that one. I'm going to divide by 5. And get y equals 1/5 x. But I got to be careful. The pointy end was towards the y. So it's less than or equal to 1/5 x. So that starts here at 0, and it rises 1 and it runs 5. It's kind of hard to tell. This is not a super accurate graph, and that's okay. because I'm going to figure out for sure. And this says less than or equal to. That means I'm shading under it. Now there's one more constraint that I haven't written, but is true in the real world. What can you tell me about the y's?
Greater than or equal to 0.
Got to be bigger than or equal to 0. What does that do? It makes a line like this, and you got to shade above. And that brings us to this final conclusion. This little green area here is the points that are in there are, oh, nope, I am wrong. You know what one burned me? This one. That line right there is shaded away from my feasible region. It's that green area is not the feasible region. Oops. Then it's got to be in here. I'll make it blue. This area, and it seems to keep going, and sometimes we do that because this is true in the real world. You could go out there and see, if you want to stay out there for 6 hours and just commune with the whales, you get pretty waterlogged, but you could keep seeing more and more and more fish, all right? So it doesn't actually have an end. So then the only two spots that really matter are where these two intersect and where these two intersect. All right, one of these is y is less than or equal to 1/5 x, and the other key one is this yellow one, which I'm gonna say is y equals negative x plus 12. How on earth are you going to tell where those two lines cross? I'm going to write these right next to each other now. Y equals negative x plus 12, and y, I'm changing it to equals, and if that bothers you, I get it, but I'm just trying to figure out where the two lines cross. I don't need the less than signs to figure out where the two lines cross. Now, there's going to be some subset of you that are going to lose some points because the only way you could do it is use the calculator. If that's you, take today to make sure you know how to substitute or eliminate. Okay, either one would work for solving this. So I'd like to take a minute and see, there's some people that know how to solve this with algebra and some that don't. We're trying to find this spot right here. I'm going to use green, that spot right there where those two lines are crossing. I want you to have a conversation with that kid next to you about which way you used, but don't use the calculator yet, please. I'm going to have to use the calculator in a minute because that's a whole separate skill that I want to make sure you know how to do. But right now, I don't want you to lose those points for the algebra. All right, talk to the kid next to you. How would you solve it with algebra?
I use substitution.
Miss Carr, how did you solve it with algebra?
Times 5.
All right, so let me think. If I times everything by 5, and that's it, I guess, then this becomes 1/5 times 5, which is just 1x. And then the negative x and the positive x are going to cancel out. Nice move. Now, if I add straight down, I got 6y equals, those two cancel out, and I just have a 12 left. Y equals 2. Raise your hand if you had y equals 2. Nice. Now, I think you get that it isn't just y equals 2. It's a point. You know, if we look back at our graph, it's a point. It's something comma 2, or a 2 comma something. All right. Well, if we figured out y is 2, it's something comma 2, and I got to figure out what that is. Well, I'm going to put the 2 back into this equation right here, and then I'll have negative 2 plus 12. Yes?
Wouldn't it be 5y? Like y is 6y? If we time it by 5.
Okay, we times this 5 times y, and we got 5y. We times it by 5 on the bottom. And then we added this y, and that makes 6y. All right. Okay, thanks for asking. So now, I've got y is 2. I'm going to stick in the 2 in this equation now. And then that's going to be y is... Oh, x, wait a minute. Y was 2. I put the 2 in the wrong spot. All right, 2 is over here. Y is 2. And 2 equals negative x plus 12, so then I'm going to subtract, I think it comes out to 10. Can anybody verify 10? Yes, 10 comma 2. All right, cool. We found the spot with algebra. We showed our work. Yay, we get credit for that. Now, could you, let's just make sure you could have. I'm going to rewrite those equations for you. Type these in. Y equals negative x plus 12. And one kid had it wrong because they weren't using the right negative sign. You know how there's a minus sign and there's a negative sign? If you use the wrong one, it won't work. And then y equals 1/5, which I would put in parentheses, x. I've seen it be wrong if you put the parentheses around the x also. So just put it around the fraction. And then make sure you remember that deal where you go second calculate, which is calculates right above the trace key. Calculate intercept. Make sure you remember how to do this. Put in these two. Make sure you know where they cross. One different one. I'll put it on the charger. Take this. Either one of these, whichever one. It's starting to charge. All right, now, I would almost guarantee that there's somebody out there who's stuck and they're not going to want to admit it. They've got the graph, but they don't know where the intersection point is because they're not sure how to do that. So this is now your job is to check. If you look at their calculator and it says at the bottom of the screen, intersection, x equals 10, y equals 2, you know that they know how to do the intersection. We all know it's 10 comma 2. The question is it on their screen and says intersection? Because they could have got the 10 comma 2 from me. All right? So make sure that they know how to do an intersection on the calculator. And if you're both stuck on it, raise your hand. I'll walk back and show both of you. I'm pausing while we make sure everybody's got intersection down. So now we've covered a lot of the skills, and we've got this crazy looking graph, and we figured out what those 2 points are. This one, if you didn't already catch it, is the x-intercept, which is where y equals 0. So if you ever need to solve for that one, think x-intercept, set y equal to 0. But this one I can tell it's 12. So that spot there is 12 comma 0. The other key point right there, I've already forgotten it. Was it 210? 10 comma 2. Thank you very much. All right, so I got 2 key points. Now we're going to do something called optimize. I haven't told you the optimized data yet, and you don't ever graph the optimized data. This is about 2 kinds of fish, angelfish and humus. Humu humu nuku nuku apu apu, crazy long name. The Hawaiian state fish. So the X, the angelfish, you're going to go write these over here. Angelfish, the X's, get you $50. Now, it's totally illegal to go catch reef fish. It wouldn't be hard at all. I'm not going to tell you how to do it because that seems wrong. But it wouldn't be hard at all to catch these fish. And then you can take them and sell them to people who want fish for their aquarium. And it's illegal to do that. You might think, well, people fish all the time and they spear fish or they catch fish and they eat them, but not reef fish. Reef fish, illegal to go grab. But people do it because they get big bucks for it. So X, angelfish, $50. Y, humus, $100. They're more rare. Anytime things are more rare, they're more expensive, as long as they're valuable. And really colorful, cool Hawaiian state fish. Some dude's probably got one swimming around an aquarium. It's illegal, but anyway. All right, so now you can write an optimized equation for this. Let's call it I for income. Because we really don't know if it's his profit. Maybe he has spent a bunch of money on, well, again, I don't want to tell you how to catch them, so, or how I think you could catch them. It's not like I have experience with this, but we're going to call it I equals, share the optimized equation with the kid next to you, please. Isaac, what'd you guys get?
I equals 50x plus 100y.
Yes. That won't ever get graphed. Okay, it's a different kind of equation that you don't graph. But we take these two key points, which were 12 comma 0, and the other one, which was 10 comma 2, there we go. And we figure out how much income we make for both of those spots, and this is the weird part. You're not looking for the highest amount of income. What? Wouldn't anybody always want the highest amount of income? The reason we're not looking for the highest one is because, think about it, we didn't have any limits on how many fish we could catch. This is still going up and up and up, and this is still going over and over and over. So what we're figuring out is the least amount of money you could make. Because the most amount of money you could make, what if you caught 100,000 humus? Like, you could get so much money because there are some real world constraints. You can't fish all day. You eventually run out of them and stuff. But our graph doesn't have like a top on it. So 10 comma 2 and 12 comma 0. Take a second, figure out your two answers for the 10 comma 2 and the 12 comma 0. Raise your hand if you're already done. Okay, awesome. Asher, can you tell me what those two numbers are?
12,0 got $600.
Okay.
10,2 got $700.
All right. So what's the least you could make doing this scam? $600. All right. So again, people often get these questions wrong on the test because they grab another point. They're like, well, this was a point where two lines crossed, but it's not part of the, there's a word for that. Talk to the kid next to you. It's not part of the what? It's not part of the feasible region. This can't be used because not everything's shaded towards that. Know what I'm saying? This one constraint line right here that's in white, right there, that line, we had to shade under it, so we aren't shading towards that spot. That isn't feasible. So people think, I'm going to grab every intersection point and test it. Mm-mm. You only grab the ones that are on the edge of the feasible region. So we only had these 2 points we could check. Right there and right there. Okay, cool. There's a problem from very beginning to very end. And it's now your job to just make sure you're ready. So the assignment that was due today, we're going to end up with 3 review days on this, which is kind of ludicrous. Okay, so there are 3 review assignments. So I'm going to just say that first one was a great practice. I hope you did it. It was good for you, but I'm not putting it in the grade book. Okay, this one that I assigned today, there's only one of them. You should absolutely do this one. Do a really good job of it. You're better at it than you ever were. Do today's, drop it in the Dropbox. Then there's one more that says optional on it. I think you know what that word means. You do not have to do that one. But there's always somebody who's like, I want to do some more practice. Maybe on Sunday. Well, there's one more with a key. Okay, so now you should be totally ready for this thing if you want to be. And the test is on Monday. And that's all I got for you for today.